Hey guys, another stream today. It's a great Wednesday so far. Got a fresh cup of coffee here. Doing a little OSRS grinding in the background here. Okay, so let's what I'm gonna do is kind of walk through some of the items that we've been working on. So we worked on scheduled reports on the last few streams. So I'll just run through that real quick. So we do have scheduled reports, and so you can add a scheduled report for critical event report, stop report, idling report. We're using an open source tool called Job Runner for this. We created some new Postgres tables, and now users don't have to run reports manually anymore, which is really, really cool. So this is still an item that's in progress. Deciding whether I'm going to be doing this on stream or offline, but we're going to be setting up a smart cron for the scheduled reports. So we have really all of the functionality for scheduled reports built out. Now we just need to set up a smart cron. And what we need to think about with this is if we have many, many different users, we don't want to try to run every single scheduled report at the same time, because that could cause some heavy load. So we're going to use a cron job to do this, and make sure maybe we only run the cron job maybe once a week on Monday, and maybe we stagger the delivery to try to make sure that we don't put too much load on our system. We scaled up a node group, so we used EKSCTL, which is an open source tool to scale up our node group in Kubernetes. Right now we're using an M5 large for our coaching solution, and this is not a GPU server. So we're actually running a depth model and an object detection model on the CPU. We're going to be trying to optimize that to make it faster. So we started reviewing some new object detection models. Let's put here, take closer. So, yeah, so we started looking into new object detection models, and I'm actually going to pull up here. So I asked Sonnet to list out what we worked on the last stream. And let's see. So we started thinking about upgrading from YOLO v4 to YOLO v8. We're looking into smaller depth models. And running on the CPU is pretty slow. We don't have enough demand for this service right now to justify putting it on a GPU yet, but that's ultimately the plan. And beginner training guide. Okay. Let's see. What tool did we use to pull down those open source images when we were working on the training? Look earlier in the chat, we weren't using Flickr, but another service. You can see it in the code too. No, keep looking. It was... It's open verse. Okay, got it. So we... Okay, so open serve. So we're gonna add this to our to-do list. We're gonna review the images that we pulled down from the web using open serve. Okay, so back going through our items, we had review new object detection models. So we're on YOLO v4. Review alternative depth models. Review the coaching system prompt. This is kind of a given. I'm going to remove that. And then build a coaching system front end. So this is not in progress yet. This one's TBD. Okay. Okay, so now what we're going to do is we're going to start preparing and getting ready to use Codex. Okay, I'm going to be using GPT-5 Codex to try to fix a bug in the next TS service. Can you run git status in that service? Can you run a git diff to see what these changes are? Okay, can you commit these changes with a nice short commit message and then push to origin? And then let's check out to a new branch and put the name Codex in it. We're going to be working on the 3JS memory issue. So we're going to be using GPT-5 Codex, the CLI tool today. And one thing I'm going to be showing you too is my billing information. So I wanted to give show my billing information here. So I have my budget set to $150. Right now I'm really having a lot of success with Sonnet 4, so I'm using GitHub Copilot right now, and if I look at the different models that are available on GitHub Copilot, I can see 4.1, so they're not charging you any additional usage costs for using this model, or 4.0, which these are the legacy models now, GPT-5 Mini, or Grok Code Fast 1. And then these models, there is additional usage cost. So I am using Sonnet 4. I've had a lot of success with Sonnet 4. It's not as intelligent as GPT-5, but it seems to get the job done and be very precise while it's doing it. You can see that I have my budgets set at $150, and I've used $29.52, and here you can see a better look at how we got to this much usage. So it definitely does cost money, but it's getting pretty cheap. And it seems to be getting increasingly cheaper. So let me close this down here. And let's go to GitHub and merge this branch into main real quick. We're going to do the rollout restart, just make sure these new changes didn't break the front end or anything. I don't remember exactly why we made these changes. We're having some type of bug in the media player. As soon as the Docker image is done building. Before we do this, let's do a rollout restart on Next.ts. I want to make sure the new commit we just pushed didn't break anything before we move on to the Codex bug fix. Better now. Okay, let's just make sure that the system's still behaving as expected. It's really the media player I'm concerned with. To be working as expected. when I press play, all here, it still doesn't play the iframe, but this is good. So another item I want to show you here is, let me open up this. Okay, so let's see. Okay, here we go. Okay, so this is one really cool thing I want to show you guys too, and we're going to be adding this to the coaching service. So one really neat thing, this is using Three.js to actually build simulation of an event, right? So this event's coming from a dash camera inside the vehicle, and what we're doing is we're taking the location data that we have available, and we're building out this simulation using Three.js to simulate or do an event reconstruction of the event. So we're going to be adding this simulation to the coaching service, and the idea is to use our AI analysis together with this 3D simulation and try to do reactive and proactive safety for our customers. So really excited about this too, and I'll play it for you one more time. So any event, we can run these simulations. We got a bug there, so we'll figure that out. Let's see if we can. Might take a minute for the buffer to load. Nice. So there is some type of bug that we'll have to work on, but you can see here the simulation does work. So really excited about this, building these 3D simulations for the AI, right? Obviously the AI does have some image vision, but it'd be nice to recreate these kind of digital twin or a three-dimensional digital twin of the event and pass that context to the LLM and see what kind of cool reactive and proactive safety tools we can build for our customers. So let me get that back over here. Nice. Okay. So we're going to do two different things in Codex at once. So we're actually going to open up our terminal, and we're going to open up Codex for two different services. Bear with me. Here we go. Okay, so what we're going to do is we're going to go into, first let's check out to the new branch. Okay, great. I tested the new commit and everything appears to be working. Let's check out to the new branch in the next TS service. Give it a name, put Codex in the branch name and something about Three.js memory. never actually do branch names like that. Interestingly enough, I guess it's... Alright, yeah, I don't want that. It's okay. Nice. Okay. So now what we're going to do is we're going to do go to cd next ts. We're going to run git status. Okay, we see that we're on our fresh new branch. Now we're going to go codex. And this is what we're going to do here. We're going to say at mapping page wrapper at mapping page native. Nice. So you can actually add the pages like that. It's pretty cool. And I'm going to say we are using Read.js to just to get added super clusters. The 3D objects are not showing on the map. I noticed this problem happens when let's see. I noticed this problem happens when the customer computer is So actually, before I send this, I'm going to copy it. I'm going to go to our chat here. I'm going to paste it in. I'm going to say, I am preparing this message for Codex. Is there anything you want to add to this message about what we recently did with the superclusters? I actually think it may have been a different chat, but let's see. If this was where it's kind of where we just worked on YOLO, I think. What I'm going to do actually is we're going back to this chat. We're going to grab this. Can you give me one paragraph and add anything I'm missing so we can send it to Codex? You know, we might just go ahead and run this without trying to optimize the prompt and see if it does a good job or not. When the markers don't appear on the map, I have to tell customers to close down all apps and restart machine. You know what, let's just, I don't feel like, I guess I could just remove it maybe easily. Let's just try this and see what happens. Nice. Now what I'm gonna do is, now we're gonna go so now let's go into our coaching directory. Can you run git status in the coaching directory? And then we're going to check out to a new branch with the name Codex in it. Do we need to commit these before we check out to a new branch? Can you run git diff and see what these changes are? I gotta run to the bank real quick. Cool. Yeah, we haven't tested these changes yet, so what do you suggest that we do? Let's do this. Okay, name this branch, or use the word codex in the branch name, but then also include that we're migrating to a new depth and a new object detection model. Okay, let's write get status. Okay, give me one paragraph message for codex. Trying to find where we worked on. I think that's all super cluster changes. Where's our, where did we talk about the coaching service? Okay, here we go. Okay, give me one paragraph message I can paste into Codex. We are going to have it I2 upgrade the YOLO low version and the depth model to something more lightweight that will work better on the CPU and remain accurate. So what I'm doing actually is I did a lot of work in GitHub Copilot, and I have some context in this chat, but the problem is kind of a bigger, or what I'm trying to implement is kind of a big job. So I think Codex might be better suited for this job. So what I'm doing is, because I have this context in the chat, I'm asking Sonnet 4 to build me a message to send to Codex. So let's see if this works. Just give me... double check, make sure that we're on the new branch. Okay. check the Git log for the coaching service and let me know what we've already pushed. Take a look at the Git log real quick. Okay, I think we just enhanced logging. Nothing too big. Okay, cool. So I'm gonna go ahead and send this message to Codex. Now, if you're just joining, what we're going to be doing is we're using YOLO, which is an object detection model, to try to detect objects in a scene. And what we're going to be doing is trying to migrate to a newer object detection model that's more lightweight, with lower latency, more accurate, but also smaller, so it can run on the CPU. And then we're also using a depth model, so we're using a pretty big depth model called DPT large. And so we're going to see if we can use maybe a smaller model that's just as accurate. So I'm sending a message right now to Codex, and I'm going to say we need to upgrade our driver behavior detection system from YOLO v4 to a more CPU efficient model like YOLO v8 Nano. And replace our Midas DPT large depth estimation model with a lighter alternative like Intel Midas v2.1 or a mobile VNet based depth model that can run efficiently on the CPU only, so an M5.large. Gotcha. Okay, so I won't bore you guys with all of this, but you can see it here on the screen. So nice. So what's pretty cool right now is we actually have Codex working on two different issues right now. So okay. So we have it working on a memory issue that we're having with Three.js. So right now on this mapping system, we built out these clusters, and I actually have this code deployed to a production system. But what's happening is, if I go to my activity monitor, so here you can see, so Three.js is using hardware acceleration. So I guess to render these 3D object markers on the map, we're using hardware acceleration. So we're using the GPU if you have it available. But what's happening is when there's many different devices on the map, for some reason, you can no longer see these markers on the map. And I think what's happening maybe is for customers that maybe only have 8 gigabytes of RAM or 16 gigabytes of RAM, if they have many different tabs open in the browser or many applications open, the browser starts to kind of starve for memory. And then at some point, I think like Watchdog or something in the background, either on the Windows operating system or the Mac operating system, is killing the hardware acceleration. And then our customers can no longer see the pins on the map. So we're, let's come back to Codex. Nice, so Codex is still working on both of these problems, which is pretty sweet. Let me pull up my to-do. So what are we doing today? We're using Codex to try to debug this Three.js memory issue. We're trying to swap to a newer version of the depth model. We're going to be integrating event reconstruction into coaching service. So let me show you the event reconstruction. And this has some minor bug. Let's see if we can get this to work here. Nice. Okay, so this is a 3D simulation, and this is an event reconstruction. So this could be an event like hard brake, quick acceleration, erratic lane departure, and we actually can create this 3D simulation of the event and move this vehicle at a relative speed. So if this vehicle got, triggered the event like an acceleration, hard turn, brake, forward collision warning, lane departure warning, anything like this, what we're going to do is take the speed and then create a simulation, and this vehicle will actually move at a relative speed, so you can kind of get an idea of what really happened during the event without having to be at the scene of the event. So we're going to be integrating our Three.js 3D event. Can't type right now. Three.js 3D event reconstruction into the coaching service. And if you haven't seen how the coaching service works today, so if I come here and I go to reports, critical event report, right now our customers will come in and run this report, and then they'll click this coaching button to do a coaching analysis on these events. So the thing with this right now is that it's only historical. So customers can come in here, look at an event that happened in the past, and then generate a coaching event. Build a confidence scoring system. So one thing we're going to be doing is right now you would click this coaching button and then we send you an email. And let me see if I can find this email for you. Just get a picture of it. Sent the coaching report, it didn't send the analysis. Interesting. But here's the idea, is that we're going to send you an email like this. We generate this AI analysis, we generate the coaching report, and we push that into S3, and then we email you with the signed S3 URL that eventually expires, and the customer can come in and download this. So let's see here. Let's see if Codex is done here. Taking a look through what Codex has done, just out of interest here. What I'm going to do is I'm actually going to try to run quickly run another coaching event. Let's see if we can do this. Okay, cool. So we did send this event. I'm gonna say, I just sent a new event to the coaching service. Can you open the logs and see if it's working as expected? See if the email comes. And while this is running, I did send, we did get a 200 OK from the service, so I'm assuming that it is executing. It's interesting though, I don't see anything getting logged in the pod log. I got a 200 OK on the front end, but I don't see anything getting printed in the log. Can you try to print the logs again? And do another one. Another request from the front end. Okay, follow the logs again. I'm gonna try to make another request from the front end. Okay. We have the logs open. I'm gonna try to get another one here. Let's see this. Okay, that's a good one. Okay. Okay, now I see something printing in the log, which is good. The reason why I'm checking this again is because, wow, Codex is still running on both of these tasks. Pretty incredible, honestly. It does feel agentic. Definitely feels agentic. Guys, I'll be right back. I'm gonna get a fresh cup here. Fresh cup of coffee. So guys, while this stuff, and it looks like the coaching is running, And while this is running, there's one item I kind of just wanted to talk about a little bit. I know in the news, there's a lot of news about the new Stargate project. You'll hear news about a different data center every other week. But I just want to ask ChatGPT, can you list out all the most recent data centers? Let's make this a little smaller so we can still see our codec stuff. Can you list out all the most recent data center projects that have been announced from the major AI players in the market? So, here's just an example of how many data centers have been announced. And, it looks like, we're at the point where OpenAI is going to try to compress all of human knowledge using publicly available data and synthetic data to try to get to AGI as fast as they can, right? Some of the AI research papers, I have not read all of them in detail, and it's something that I want to do. But my understanding is, according to the research, they have understood that if they bring X amount of compute online and they use X amount of data to train a new model, that the model gets a certain orders of magnitude more intelligent, right? And as long as I guess that scaling law stays true, Wall Street will continue to dump money into this, right? Now, I don't think anyone knows what the future will bring, and if we build these data centers and use synthetic data to train these models, will we get to AGI or not? But apparently, AGI would be such a transformative technology for the human race that Wall Street is willing to take a big bet on that. Now, the interesting thing is there's a lot of money, institutional money flowing from endowments and other funds into this, right? And the question is this a bubble or not? Now, really, the one item that I wanted to talk about, really, the reason why I brought this up is because there's a pretty serious demand for fresh water and energy from these data centers. And what does that mean? That means that this will have some sort of societal impact on society because of the demand for energy and fresh water. And it's my understanding that they're also looking to essentially put these data centers anywhere where they can get access to electricity, right? And, some regions, the politicians in some regions may see a data center and think, oh, great, this is new jobs coming to my region, which is true. But I think there's maybe not a good enough understanding of what the demand. These data centers have a serious demand for fresh water to cool the compute, and also energy. So just something to think about. Don't want to get too deep on these topics, but definitely something that's interesting. Now, another item I'll talk about is, a lot of people say that AI is going to bring more jobs, which I think that's true. And people will reference the horse and the buggy, right? That, you know, there were all these jobs where we were essentially maintaining these horses, or any job that was related to horse transportation went away, right? But then you had all of these new jobs that were created. But one interesting item to kind of think about is that, sure, there may be new jobs created, but what type of jobs are going to be created? Are they, because right now the jobs that are getting replaced are really the like entry-level college graduate data entry jobs, or anything that doesn't require an incredible amount of strategy and deep thinking, right? And so what jobs will come, or what jobs will replace that job? And that, I guess we don't know that yet. But I've heard some smart people talk about how, yeah, there'll be more jobs, but there's going to be more lower level jobs and more higher level jobs. So jobs upstream and jobs downstream, but those entry level jobs are gone, right? And so what are the lower level jobs? That might be like annotating data to train models, right? And what are the higher level jobs? Probably the best of the best, the brightest, the smartest engineers are going to be the ones that are kind of guiding these models. But anyways, just thought I'd have a little fireside chat there with the chat. Let's see. Let's get back to work here. Okay, so let's check out what Codex did. It looks like one of the codecs finished. So here, let's check this out. This is pretty cool. Nice. Okay. Okay, markers were disappearing because our map overlay ran an endless request animation frame loop and kept every CSS 2D cluster object around on machines where Chrome drops hardware acceleration under memory pressure. The WebGL context dies, and since we never handled that failure, the renderer stayed null and none of the 3D markers came back. Nice. So they added a 2D fallback, aggressively clean up resources. So what's interesting is, okay, it's done now. So now I guess I ask it to, I'm just going to say, and this sent the email. Nice. Here's an example of the coaching email that just got sent. And I know we're bouncing around, guys, but bear with me. We'll kind of focus up here pretty soon. But so here's the example of the AI coaching email that just got sent to me with the S3, the signed S3 URLs. And so what I'm going to say now is I'm just going to close this down, and I'm going to say, great, Codex just finished running in the Next.ts repository. Can you run a git status and then run a git diff to see the changes that they made? I'm actually going to ask GPT-5 if I should be using Codex. And it's kind of a easy answer, I guess, but should I be using Codex to also commit the changes and push to origin? Nice. So yeah, it's probably not the best tool maybe to do like one-off git push origin, stuff like that. But what we're going to do is we're about to find out what changes it did make. So I'm using Sonnet 4 now. I used Codex to go identify the issues. And we'll run through the changes again. So it added cluster icon data caching. So we stop regenerating SVG data URLs every frame. And introduced cross-environment base64 encoding. We centralized map overlay bookkeeping in the refs, in the references, cache supercluster membership by device ID, and reuse the last cluster result when checking hover selection. Replace the perpetual animation loop with an event-driven scheduler that queries a single frame when inputs change. Cutting constant GPU churn. Added robust WebGL context loss handling. So it's like robust cleanup. Propagated context loss, restored callbacks through the overlay wrapper and underlying Three.js overlay so the React layer can react correctly. Okay. So, if you're just joining, guys, I have a bug right now. This is Three.js and Google Maps, and we're adding 3D objects on top of a Google Map using a Three.js overlay, and we added these super clusters to the map, and I pushed this. This is a staging system, and this code is running in production with real customers on it. And we pushed it to production, and we had a customer mention that they couldn't see their 3D objects on the map. So we're using Codex to try to debug that, and usually what my understanding of what happens is Three.js is using hardware acceleration. So Three.js is using your computer GPU to try to render this 3D map in the browser. And that uses something called the Chrome GPU helper to do that, right? And I think something with the way that we have this implemented is pretty heavy on memory. And if your RAM utilization gets too high, then what will happen is it's Watchdog and Mac, but a background process will kill the hardware acceleration to try to stabilize your system. And so you won't be able to see these 3D markers on the map anymore. So this is an issue. So what we're trying to do is optimize this code to make sure this doesn't happen anymore. And so again, what will happen is this Google Chrome GPU helper, I can't talk right now, will spike. If you're doing a lot of zooming in and out, these pins also move live on the map. So we're actually also pulling in live data, and I can try to show that to you. Let me see. Okay, so this is actually Kafka sending data from our listener service that ingests the data, and then this front end listens to a Kafka topic. So we have a lot of different things going on. We have the 3D objects moving around the map. We're trying to do clusters. We're trying to run an animation frame loop, and so it's causing some issue. So let's see what Sonnet said here. Let's actually log out real quick. Just Okay. Nice. Okay, so let's see what Claude Sonnet said. Okay, can you commit these changes with a short and sweet commit message and then push to origin? And I will let you know when the Docker image is done building and we can do a rollout restart and test. So let's see. Okay, let's see what the coaching codex is saying now. Okay, so what happened here? Replace the YOLO v4 OpenCV stack with a CPU-focused YOLO v8 detector. Okay. Introduced a lightweight Midas depth estimator with selectable backbones. Okay. Rework the processing pipeline. Updated startup to warm the CPU models. Added compatibility shim so legacy imports stay valid while pointing at the new. Okay. First, let's try these coaching changes. Or let's commit these coaching changes. We are in the wrong directory. I think we want to go to the coaching directory and then run git status. And then let's add and commit these changes and push to origin. Will we be able to push all of these images? Guess I could have just tried that. Can we just not commit all of these images? Alright, that goes backwards one commit. What does git reset do? Will that wipe out all the changes that Codex just made? Got it. Okay, so git reset soft head goes back one commit, but keeps all the changes staged, so you could recommit them with a different commit message. And then git reset unstages all the changes, but doesn't. What's in the train folder now? Search again. I know. .jpg. Let's run back to the bank, guys. Keep that RuneScape grind going. Okay, let's deposit our U-logs, guys. Get back to chopping. We're trying to get to level 75 wood cutting so we can chop down the magic trees. Make sure the YouTube thumbnails working. Hold on. So, let's see. See if we can get this merged here. Let's wait for that to finish building. Okay. So, hey, if you're just joining, we're testing out Codex. We're working on a coaching solution. And let me pull that up for you here. So we're using an object detection and a depth model right now, and we're using Intel DPT Large and YOLO v4, and we're looking into an alternative object detection model and also an alternative depth model that's more lightweight and just as accurate. And we're using Codex to help us do that. And we also have a 3JS memory issue going on. So we built these 3D objects with clustering, but they are kind of heavy. Or this 3JS 3D rendering is a bit heavy in the browser. And these pins move live, so we send data live to these devices. We send data live, so these objects are constantly moving around on the screen. And this is a 3D overlay on top of Google Maps. And another thing we're going to be working on is this simulation using 3JS. So we're going to be adding that to our coaching service too, to help us build the event reconstruction. And we're going to put all of this on a front end. Right now, when we do this AI analysis, we just send an email. But we're going to be adding this all to the front end. And I'll show this for you here. So this is the 3JS simulation. Really, really cool, actually. And not many people in the market today are even doing this. Let's come back here. Okay, so let's see if we can merge this branch now. Come to GitHub. Docker image is still building. I had to merge an old PR first before we merge these major changes. This is what it looks like. This is what it looks like when the image is building. So it's building this image. It's about to push it to Docker Hub, and then we can proceed. Did we push? I don't even remember now. Did we push to the next TS service? Okay, so let's go back to GitHub here. Where are we? Okay. We lost our GitHub window. Okay. Oh, here we go. Okay. That image is still building. Coaching service takes forever to build, actually. It's pretty big service. Okay, move back. Okay, we didn't push it. Okay, Codex also finished the changes in Next.ts. Can you run a git status there, commit the changes, and push to origin? I want to make sure that we don't commit a bunch of like untracked changes and stuff. No, it's just these changes. We should be good. So let's go ahead and commit these changes. And then we're going to push them to origin. Merge those changes. We're also merging the coaching service changes, and those images are building. These images are building. Okay, so is the coaching service ready to test? The Docker images are building for Next.ts and the coaching service. I'll let you know when we're ready to do a rollout restart. So if I make a request from the front end, is it going to run through the new optimized flow? Okay, so codex looks like it did fail here. Let's see. Or the codex changes to the front end did fail. Can I paste this into codex? Let's find out. The next TS build failed. Can you review this error? Now I'm kind of going back and forth inside this one thread on the coaching service and next TS. It seems to be able to handle it seems to be handling kind of switching context okay. So I haven't felt the need to open up a new chat yet. And hey, if you're just joining, we're testing Codex. We just had it work on some pretty serious bugs here. We're building a coaching service with, let me see if I can pull this up for you, using depth and object detection models. So here's another, let's play this for you too. So we're using Intel DPT large to build these depth maps to see how far away these objects are from the vehicle. And then we're also using YOLO v4 for object detection. And this is a 3JS event reconstruction simulation using 3JS. And we're going to be adding this. We're going to be adding this to the coaching service and building a front end for this. So here's actually the event simulation, which is really, really cool. So let's go back to VS Code. Okay, it was just a type error. Let's see if this fixes it. Okay, so let's go back to GitHub. Let's try to rerun this build here. See if this builds without failing. Back. Okay, nice. That fixed the type issue. So I'm going to tell... So I'm going to tell it to... Okay, great. That worked. Can we do... Oh, no, it failed again. Hold on. Thought it worked, but it failed again. Let's see. So Codex did have some TypeScript. The way that it works is that I merge that branch into main on GitHub, and then GitHub Actions builds the Docker image. So guys, we're gonna find out if Codex just broke the code. I already did merge it. Oh, let's try to do another PR. Maybe I didn't. You know what? I thought the PR was still open, so the latest push executed the npm build again, but it looks like I need to create another PR. Let's see. Okay, there we go. Here's the TypeScript error fix. All right, I'm merging this into main. Hey, if you're just joining, we're working on some pretty cool stuff. We're working on a coaching service. So we're using an Intel depth model called DPT large, and also an object detection model called YOLO v4 to do an analysis on dashcam video. And then we're also building these 3D simulations of event reconstruction. And we're going to be, and this has some issues. Let me see if I can get this simulation to run for you. Okay, there we go. So we're also going to be including this simulation in the coaching service and building out a front end for this. And if you're joining, thanks for being here. Please like and subscribe. It helps a lot. And you can follow along with this journey of vibe coding this coaching service. And also we're going to be working on agents, all stuff AI. And right now we actually used Codex to work on some of these issues. Now there was another issue as well that is a 3JS issue where it's using too much hardware acceleration, is using a lot of RAM. And these are 3D objects that move around on the map as the vehicle moves. And what happens is, for customers that have a machine with not a lot of RAM, hardware acceleration will eventually fail, and you'll no longer be able to see these 3D objects on the map. So let's go back to GitHub here. Nice, that builds. sure we're still chopping. Okay, nice. It finished building. Let's come back to VS Code. I'm gonna say, okay, next TS finished building successfully. Let's do a rollout restart. It always forgets the deployment name, but that's okay. It's been a big thread. Hey, if you're just joining, we're working on some pretty cool stuff right now. We are building a coaching service. So we take a dash cam video, and we're using a model called Intel DPT Large to detect the depth of these objects. And then we're using YOLO v4 for object detection. And after we detect the objects in the scene, we try to build a coaching report for drivers. And we're also going to be including this 3D simulation in the coaching service. So we're using 3JS to build this simulation of the event. And there's a little, has some small bugs here, but let me see if I can show this simulation. And if you're just joining, please like and subscribe. It helps a lot. And love to have you here. I appreciate anyone at any skill level. Feel free to ask any questions. I'm happy to help. Just going to be vibe coding. And you can follow along with my workflow and see what I'm working on. We're going to be working on video safety stuff, and also voice agents and digital employees. So miniature digital employees. So not to replace the human, but to assist the human. So a lot of cool stuff we'll be talking about during this stream. So let's come back here and see. We're about to do a rollout restart. This whole system is deployed on Kubernetes, AWS EKS. And I have the entire, it's like about 13 microservices in this code base. And we have AI has access to the entire system, including AWS EKS. Nice. So we just did a rollout restart on the front end, which is a responsible way, essentially, to restart the pod without downtime. Let's see. Okay. It's interesting. Things are snappier, I'll tell you that much. So this could be other Chrome tabs. Really, I'm on stream now, but at some point I'm going to shut down every process and only open this to see how much. So this is using hardware acceleration. So it's using the GPU. I don't like how it's doing that. We're going to have to figure that out. So what I might actually say in Codex is I might tell it that. Let's see what Codex can do. Say. When I click on the map and move the map around, when I click and hold, and this is GPT-5 Codex, and hold, when I click the map and click and hold on the map, when I click and hold on the map and adjust the position, I don't really know how to word this, position of the map, the cluster will fly around. The cluster should always stay in the same position of the markers that it is clustering. I'm trying to word this better. Let's see if GPT-5 is probably not going to be able to help me. Whenever things like this are happening, it's hard to describe it. I don't know how to put this into words here. But let's just see if Codex can get this. I'm going to say when I click and hold on the map, fly around, but then eventually snap back into the right position. Should always stay in the same position of the markers that it is clustering, even if I'm dragging the map around. Let's see if it can get this. Okay. Hey guys, if you're just joining now, we're using Codex to work on some different problems. So this is Three.js actually. This is a Three.js overlay on top of Google Maps. We're using superclusters to cluster these pins. And this is using hardware acceleration. So to do this 3D rendering on the map, it's actually using the computer's GPU. And this is actually a 3D object. So if I come into this map, you'll see that it's a 3D map. This is a 3D object that's on a Three.js overlay on top of Google Maps. And what's happening is for customers that have 8 GB machines, running all of this Three.js stuff gets a little heavy. So if they have many different tabs open, they might have like a noisy neighbor effect where we may only be using 2 GB of RAM, but other programs are also using RAM. And when their RAM utilization, and some of our customers have many different pins all over the map, right? And these pins are, that's kind of interesting there. Yeah, so our customers will have many pins on the map, and these pins are all getting clustered with these super clusters. So when there's many different pins on the map, this gets a little heavy. So we asked Codex to work on this before, and I said, let's see what my message was. God, it did a lot. And the Codex does feel pretty agentic, I have to say. And before I show you what I said to Codex, I'll show you the other items we're working on. So we're also working on this coaching service. So we're using a model called Intel DPT Large and a YOLO object detection model to build this depth map and to detect these objects in the scene. And the idea is if you have a camera in your vehicle, that we can take an MP4 video and do this AI analysis on the video, try to detect the relevant objects, and if those objects are within a distance to where they're even relevant. And then what we do is we try to take that, build a transcript, send it to OpenAI, or whatever LLM we decide to use, and return coaching questions for us. So that's what we're working on. And so we asked Codex to work on these two different problems. Now, the clustering problem, I said we are using, we are using Three.js together with Google Maps to add 3D object markers to the map. We're using Kafka to send location data to the front end. And when we get new data, we redraw the 3D objects on the map. We recently added superclusters to the Three.js Google Map. Today we had customers that were complaining that the 3D objects are not showing on the map. I noticed that this problem happens when the customer's computer has high RAM utilization and then the hardware acceleration stops working or something. Can you figure out why this is happening, and let's make this more memory efficient? And so that's what we have it working on for the Three.js problem. And then for our coaching service, we're wanting it to work on this. So we need to upgrade our driver behavior detection system from YOLO v4 to a more CPU efficient model like YOLO v8n. So another thing that we're doing right now is we have this coaching service running on a CPU. So we're using an M5.large. We don't have enough demand yet for me to justify using a GPU server from AWS. The GPU compute is kind of getting a little pricey. But we need to upgrade our driver behavior detection system from YOLO v4 to a more CPU efficient model like YOLO v8n. And then we're going to try to replace DPT large with an alternative that's more lightweight. And hey, if you're just joining, please like and subscribe. It helps a lot. And if you have any questions, please ask me. I'm here vibe coding on video safety stuff, and also going to be working on AI agents. And we're doing some old school RuneScape kind of skill grinding in the background, just doing some wood cutting. We're using Codex right now to debug a Three.js issue. And also we're having it do some analysis on our object detection model and also our depth model, and we're trying to do a refactor on that service. So let's see. I just told it pretty much Codex was made some major optimizations to this service, and now I showed you what I asked Codex to do, and now let me tell you what it actually did. Okay. Say it does feel agentic, the way that it kind of continues to work. Okay, so this is what it said it did on the cluster changes. So markers were disappearing because So what happened is we have some customers that have many different vehicles, and if their RAM utilization gets too high, because Three.js is using this hardware acceleration, or if they don't have a lot of GPU compute, eventually, in my case, if I'm on a Mac, I think it's called Watchdog, which is a operation that's running in the background, and I guess it's looking for programs that are spiking with high memory, and if your RAM utilization gets too high, I believe that Watchdog is actually killing hardware acceleration. And what happens is, actually, these pins won't show up on the map for our customers. So I added these super clusters, and I think that maybe these super clusters are using a bit more memory. And so we asked Codex to try to figure out, hey, how can we make this more memory efficient? And so Codex said that markers were disappearing because our map overlay ran an endless request animation frame loop and kept every CSS 2D cluster object around. So it looks like we had some objects hanging around in memory that aren't supposed to be hanging around in memory, and that's not good. And hey guys, if you're joining, please like and subscribe. It helps a lot. Feel free to ask any questions in the chat. I'm happy to help and answer. Doesn't matter what skill level you are. You know, I at one point wasn't this advanced, and we all start somewhere. So happy to answer any questions to the best of my ability. Obviously, I'm not an expert on everything. So on machines where Chrome drops hardware acceleration under memory pressure, the WebGL context dies. And it looks like we're not properly handling that failure. And the renderer stayed null and none of the 3D markers came back. So what did we do? We added some cluster icon caching. So I guess we're like regenerating an SVG on every frame, and so we don't want to do that. So we introduced some caching. We introduced some bookkeeping and references. We replaced, I guess there's an animation loop that's running constantly, and we did more of an event-driven behavior. We added some garbage collection, pretty much, it looks like. And then we added some callbacks, it looks like. So then I asked it to do something else. I said, when I click and hold on the map and adjust the position of the map, the cluster will fly around, but then eventually snaps back into the right position. I feel like I really didn't word that great at all. The cluster should always stay in the same position of the markers that it is clustering, even if I'm dragging the map around. So what's happening is when I'm zoomed in, or if I click on the map and drag the map around, you see how that cluster is moving? It will snap back to the right place, but I don't know if that's a good thing or why exactly that's happening. I'm trying to understand. So it started working on that problem, and what did it say? Clusters now stay glued to their member markers while you drag the map. Each badge records its lat long, and during every scheduled frame we recalculate its 3D position. Camera shifts, never leave the badge behind. Okay, cool. So now, and I haven't decided, I'm Codex, I haven't used it yet to make my git commit and push to origin, and I'm not sure how that works. I don't know if Codex is smart enough to where if I ask it right now, can you commit these changes and push to origin? And we can maybe try in a minute how long that will take, if it'll do a lot of reasoning, you know, and I don't really want to do a lot of reasoning for something that's that simple. So let's restart the coaching service real quick. Now let's talk about the bouncing, switching context again here. So that was the cluster fix that we just talked about, and we're about to commit those changes and push them. Okay, Codex just made more changes to Next.ts. Can you run git status and see exactly which files we changed, commit those exact changes, and write a short commit message and push to origin? It wasn't actually a memory change. Hold on. Can you run git diff and maybe do a soft head restart? I think you gave that commit message a wrong description. We actually just fixed the cluster flying around. Kinda, I do feel like we're flowing. We're flowing. It's not too critical to change this commit message, but it helps when we're having to go backwards. So now we're going to do a git reset soft head 1. So what that does is we're going to go back to the previous commit, and our changes will still be staged. So then we'll just be able to change the commit message. So we won't lose our changes, but we'll undo that commit, and the changes stay staged. Please like and subscribe, guys, if you're here. It helps a lot. And feel free to ask any questions. Doesn't matter what skill level you are. I don't discriminate. So nice. We just made the commit. Now we're going to push to origin. Okay, nice. Now let's push to origin. So the first thing I noticed about Codex off the bat is that I ran it, pushed the code, tried to build the code, and there was TypeScript errors. Now, I don't know if there's something about, and I haven't really tested enough to give definitive statement on this, but one thing about GitHub Copilot in the IDE, and I don't know if there's better linting or better TypeScript kind of type checking inside of the IDE, but I had been flowing with Claude Sonnet 4 inside of VS Code for a while, and hadn't had a like a basic TypeScript error like that in a long time. Now, good news is that it was a easy to fix error, and I quickly fixed it, and it started working. And it definitely went pretty deep. It's pretty amazing how deep it went, actually. Grab a water real quick, guys. Be right back. Okay, Docker image is building. Looks like Docker image failed with another. Let's see if it's another TypeScript issue. Interesting. I don't know if Docker is down right now. It's kind of weird. GitHub, or let's go into a Docker Hub. There was an error authenticating your account. Well guys, this might be a stopping point for today's stream. Really weird. Interesting. Okay. Something's going on with Docker. Okay, nice. Issue authenticating with Docker Hub. Okay, I got nervous for a second. Okay. Thought we got hacked or something. So, all right, guys, I think that, Docker's down right now, and it's probably a good stopping point for the stream. I think we talked about a lot of interesting stuff on this stream, and definitely looking forward to the next stream. So anyone that tuned into this stream, I appreciate it a lot. Let's try one more time. Maybe we'll get lucky. Okay, yeah, Docker's still down. Well, guys and gals, this was a great stream. Really had a good time during this one. But anyways, thanks for joining. If you joined, please like and subscribe. I'll see you on the next stream.